Well, what are, first of all, what are inverse trig functions? Let's start off with this idea. You might be familiar with these guys: sine of theta, cosine of theta, and tangent of theta. Those are the big three trigonometric ratios, and they also happen to be functions. We usually, we're doing sine of theta or cosine of theta or tangent of theta. And the opposite of those guys is called the inverse, like we have sine to the -1 of something. I'm gonna save off what that is till later. Or we could have cosine to the -1 of something, or tangent to the -1 of something. These guys are known as inverse trig functions. Inverse sine, inverse cosine, inverse tan. And what we put in there will make more sense if I show you in an example. So we're going to start off with an example problem. For this example problem, we're going to call this the kite. Why not? Makes it a little bit more fun. I like kites. I hope you do too. So you have 300 meters of kite string on a spool. A spool is like something where the string is all wound up on, and you let all of it out. You put it on the kite. It's a windy day. You let the kite go. The kite goes up into the air, and you let out all the string. So that sucker is 300 meters away from you. And here's the question: what must the angle of elevation be for the kite to be 200 meters above the ground? So we're going to try to solve this problem. So first thing we do when trying to solve trig problems is we draw a sketch. Let's start off with that. And I'll try to do as good one as I possibly can. Right triangle there. The length of the string is about 300 meters, and in this particular scenario we're interested to know, we'd like this kite to be 200 meters off the ground. Who knows why? Maybe we're using this to maybe we have a camera on the kite and we want to do some filming. Maybe we're checking out some habitat, maybe possibly of an eagle. Who knows what the reason is. So the issue is this, though, is that in order to figure out how to get that kite to 200 meters, we need to know what this angle is. And if you don't mind, I'm going to call it theta, the Greek letter theta. And also, this particular angle, the angle from the ground, has a special name, and that's called angle of elevation. So in some problems you might see something where they're looking for, they tell you about angle of depression, and angle of depression is just if you're up here and you're looking down, angle of depression is right over here. That's a little bit of an aside, but let's get back to business here. So we want to find the angle of elevation here that's required in order to get this kite 200 meters off the ground. We know we have 300 meters of string. We just want to have a sense of when that kite is 200 meters high. So we can use some trig to get this answer. Now, one of the things we know is that because the 200 is across from the theta, and the 300 meter is sort of our hypotenuse of our triangle, we could use the trig ratio sine. And the way we would do it is we would write the sine function, sine of theta, and we would say it is equal to the opposite side, 200, divided by the hypotenuse, which is 300. Now the only problem with this is we don't know what theta is, and it's sort of trapped in the middle of this sine function. So what we'd like to do is we'd like to untrap that theta. And the way we do it is we use this thing called the inverse sine. And what we'll do is we'll apply this to both sides of the equation. And I'll show you why we do that in just a second here. So let's go ahead and finish this off. We got to do the inverse sine. Whatever you do to one side of the equation, you got to do to the other. Remember when we, well, there's a number of times where we've had to do that. And I'll give you a quick reminder. But there we go. We took the inverse sine of both sides. Let's take a quick refresher look at why we do that. You might recall problems like x squared equals 25. We want to get the x all by itself, but there's that nasty exponent there. So what we do is we square root both sides of the equation. Okay, so you're happy with that. Hopefully you have no qualms about that. But what if we didn't use a square root symbol? What if instead we wrote x squared equals 25, and instead we wrote out the function in this way, square root of x squared. And we'll try to do the same over here. There we go. Square root of 25. Hopefully, you'd be able to do exactly the same thing. We're still going to get x over here, and we're still going to get 5 over here. We're just applying the square root function to x squared and the square root function to 25. That's what we're doing with this inverse sine. We're applying this inverse sine function to the sine of theta and the inverse sine function to the 200 over 300. And by the way, this is not all that different from what we did when we were using the regular old sine. By the way, you don't need to write all this. This stuff right here was just for example. Just wanted to show you a point. But remember when we did this, you don't need to write this either. When we do sine of 30 degrees, even this is just a function. You know, what is sine of 30 degrees? Sine has no value. 30 times sine doesn't mean anything. But if you put 30 in your calculator and you hit sine, you get a number over here. This is called the sine function. This up here is the inverse sine function. So anyways, let me clean this up and let's get on with our math. So the neat thing about the inverse sine function when it's applied to the sine function is these two things sort of undo each other. These two sort of cancel, and what we're left with in the end is simply just theta. So that's pretty cool. And then over here we're stuck with the inverse sine of 200 over 300, which if you wanted to, you could simplify that as 2 over 3. That would be fine also. And it turns out most of our calculators have an inverse sine function. Good scientific calculators do. And you just put 200 over 300 in, get the result, and then hit inverse sine, and then we'll figure out what theta is. Let's try that on our calculator. So we'll do, if you don't mind, I'm just going to do 2 divided by 3. It's the same as 200 divided by 300. And then we're going to go ahead and instead of sine, I'm going to do inverse sine. And that gets us a result. Oh, whoops, I'm in radian mode. That's something you got to watch out for on your calculator. Don't just, you know, I was looking at this and I'm thinking, hey, that doesn't look like the number of degrees that I'm expecting here, 0.72 degrees. I was in radian mode. Let's try that one more time. We're going to do 2 divided by 3 equals, and then we'll do inverse sine. There we go. And we end up getting about 41.8, and that is in degrees. So let's go ahead and let's add that in. So what we figured out is theta equals, and what was it again? 41.8 degrees. 41.8 degrees. Yay! That's pretty cool. I'm pretty happy about that result. So now we have a method for figuring out an angle if we know hypotenuse and, well, if we know two sides to a triangle, we can figure out an angle using this inverse trig function, the inverse sine. Here we got 41.8. If this was really a practical application, 42 degrees might be more than sufficient. Heck, 40 might be okay. You might wonder, well, how do we measure that angle? Well, if you don't mind, I'm just going to go down a little bunny trail here for a second, because there's a couple of cool things that I wanted to share with you. First of all, it turns out that back in the old days, when sailors had to navigate ships and they had no GPS, they had this device called the sextant. And the sextant, this guy here, actually lets you figure out where you're at on the planet by you sight the horizon here, and then you line this up with the sun, and it can also be used with the stars as well. And it gives you a sense of where you are on the planet. And of course, it's measuring angles when it's doing so. Another device that measures angles, sort of like in our problem here, is something called a theodolite. Another fancy word, you know, first we have sextant and then we have theodolite. And this guy's a theodolite, And what it does is it lets surveyors figure out whether, how to make sure that the construction they're doing is level, and that's good for roads and it's good for buildings, and it also lets them determine distances that are accurate in level. So what about yourself? What if you don't have a sextant or a theodolite and you want to know, you're out there with your kite, you're a young Ben Franklin, and you want to figure out that angle. Well, you could make your own device, and this guy has another fancy name. It's called a clinometer, and you just use a protractor and a string and a straw, and heck, we might even do this in class ourselves. Anyways, just wanted to give you a heads up that there is a way to make a device to measure angles like this, if you wanted to get out there and use this math for some practical applications. Now, we're going to do one more problem so you can see one more inverse trig function demonstrated. So here's one more fun little problem involving inverse trig functions. Here's the situation. You're reading a book. The book is on the desk in front of you. It's about 2 feet below your eyes, and it's about 1 foot in front of you. Pretty common, reading position. And so in order to read this book, you're going to have to tilt your head or tilt your eyes or something. And so we're just going to take the idea that maybe you need to tilt your eyes down to look at the book. And so we're going to ask the question, what is the angle of depression for your eyes to read the book? So first, it'd be nice if you could draw this diagram. Why don't you go ahead and pause the video for a moment and see if you can draw it? Because if you're going to answer questions on a test that are for problems like this, you should be able to draw the diagram and then figure out the problem. So hit pause, and then we'll see if we agree in a second. Okay, let's see if we agree. So what I would do is draw a picture like this. Now, depending on whether you're more interested, that's a little on the long side. Let's make it a little shorter. There we go. Depending on whether you're thinking of looking to the left or looking to the right, maybe we'll go like this. And we're saying that, maybe your eyeball's over here, something like this, right? Maybe, there we go. A little more menacing eyeball. What do you think? Anyways, so you're looking down here at the book, and the book is about 2 feet down here, and it's about 1 foot away from you, something like this. And what we'd like to know is what is the angle of depression, and the angle of depression is this angle right here. It's the angle looking down from the horizontal, as opposed to the angle of elevation, which we saw in the last example. So let's go and do some math. What we're going to need, this is the opposite side over the adjacent, so we're going to need the tangent. So we'll say tangent of theta, and that is equal to, it looks like, again, opposite over adjacent, so 2 over 1. And what we're going to do is we're going to do the inverse tan, but instead of doing that middle step like we did a few, last time, instead of doing this deal where we write out all this stuff, if you don't mind, we're just going to go right down to the step where we say theta equals the inverse of whatever, okay? So we go from sine of theta equals 200 over 300 to theta equals inverse sine of this. Let's try that method. It should be a little bit more efficient in problem solving. So what we do is this. We simply say theta must equal the inverse tan of 2 over 1. And if you don't mind, I'm just going to rewrite that as 2. So notice how I skipped the middle step. Makes it cleaner, makes it easier, means that you'll get it correct more often. And then here we'll go ahead and use our calculator to figure out what that's going to be. So we go ahead and clear this guy out, and then we'll go ahead and enter the number 2, make sure we're in degree mode, and then let's do inverse tan. And when we do, we get about 63.4 degrees. So our theta is, let's see here, theta equals, and what did it say again? 63.4. And that answer is in degrees. There we go. Okay, so we use the inverse trig function to find the angle. Okay, so now we've used a couple of inverse trig functions. We used sine, we used tan. There's also an inverse cosine. And we used it with angle of elevation and angle of depression. So hopefully this is a pretty good example to help you out with this aspect of right triangle trigonometry.